we can start the A2 electrochemistry. Okay, just a quick recap that okay, what we did yesterday was that we figured out how to figure out oxidation states. Okay, I told you that in a compound, electrons are closer to one atom, so that is the one that's gaining electrons. The other one is the one that's losing electrons, and that's how you come up with these oxidation states. In oxidation states, we don't really care whether the electrons are completely gained by one atom or not. Even if they're slightly closer to one of the atoms, then we say that it has gained electrons. You're already familiar with how to find oxidation states. And we learned how to, I mean, this is important, because in A2, you're going to do a lot of this. So we're going to try and balance some of these equations that I gave you. Okay, let me try and balance them again. Okay, so this is what we are doing in redox reactions. You were supposed to figure out oxidation states, and just hold on a second, let me sync this. Just 1 second. So ठीक है चला गया. अच्छा, this equation, ठीक है. Let's try and figure out how to balance this equation. So you've got phosphorus, which has an oxidation state of 0 because it's a neutral free element. You've got NO2 minus 1. तो उसमें what is ये किया था कि नहीं किया था? What is the oxidation state of N over here in NO2 minus 1? क्या आ रही है? Anyone? कितनी है?
+3.
ठीक है, this one is +3. O and H are O is -2, H is +1 everywhere. ठीक है, what is oxidation state of P over here? N is definitely +1. What is P?
+1.
Confirm it, +1 है.
Yes, sir, +1.
ठीक है, that's +1. अच्छा, so we have to balance the number of electrons gained and lost. So N goes from +3 to +1. So that's a gain of 2 electrons. And your P goes from 0 to +1. So that's a loss. That's a loss of one electron, right? So now the thing is that there are already 4 P's. So I'm going to start with 4 P's. Okay? So there are already 4 phosphoruses. Because I was talking about just one phosphorus, so that was losing 1 electron. So you already have 4 phosphoruses in the equation. So I just multiplied it by 4. To balance the number of electrons gained, this should be multiplied by 2. So there should be 2 N's. So there should be 2 N's over here, and there are already 2 N's over here. So now it's balanced. The electrons gained and lost are equal now. पीछे क्या रह गया? You just have to balance OH ions, and you have to balance water molecules. That's the only thing that's left. So how are we going to do that? इसमें क्या होगा? Is it how many oxygens do we have? I mean, there are 2 H's.
We'll add hydrogen.
नहीं, एक second. sorry, this is 4 p's, right? So this has to be multiplied by 4. ये गलत किया हुआ था. I mean, it's supposed to be 4 p's. 4 p's here, 4 p's here. I said now you don't. So that's 8 hydrogens. Okay, 8 hydrogens on this side. So in दोनों को balance करना, that's going to be slightly tricky. How many oxygens do we have? We've got 4 oxygens over here.
9.
नहीं पहले इनको हटा देते हैं. You got 4 oxygens, you got 8, and so you basically need 9 oxygens on this side, right? So there are 9 oxygens on this side, so I need 5 oxygens. So 5, yeah, basically I just need 5 oxygens to go over here. So I would just try numbers, and see if the H gets balanced. So 5 oxygens, right? So I can start off with 1 over here and 4 oxygens over here. अब इसको देखो, is the H getting balanced? ये समझ आ रही है ना कि I had 4 oxygens over here, I had a total of 9 oxygens, so I just needed 5 oxygens in total. So I'm just doing trial and error now. So 1 oxygen here, 4 over here. So H कितने हो गए? That's 8H plus 1H, that's 9H. Over here I have 8H, right? So that means the H is not balanced. So I'm just going to try another number, okay? I'm going to try 5 चाहिए ना, so I would take 2 and 3 over here, so that's 5 oxygens, so 5 plus 4, that's 9, so that's balanced. So there are 2 H's and 6 H's, so that is 8 H's. You got 8 H's, ठीक है? Now it's balanced. ठीक है? Is this clear? ये वाली equation, is this clear?
Yes, sir.
ठीक है, so सारों को clear ना? Ahmed, Tasneem, is this clear?
Yes, sir.
Yes, sir.
Okay. So then just very quickly, just a little bit, just a small point on disproportionation. What is this? क्या होता था disproportionation? What was that?
When one element loses and gains electrons in the same reaction.
ठीक है, so when the same element gets oxidized and reduced. Element gets oxidized and reduced at the same time. ठीक है, in group 17 you were supposed to remember one of the equations, which was this one, that Cl2 was reacting with NOH, and अगर वो hot NOH के साथ if it reacted, then it would produce NaCl and NaClO3 plus H2O. So to balance this equation, you're going to balance it the same way. Cl has an oxidation state of 0. In NaCl, Cl has an oxidation state of -1. In NaClO3, it has an oxidation state of +5. So basically, Cl is going from 0 to -1, and at the same time, it's going from 0 to +5. So that means it loses 5 electrons, but at the same time, it gains 1 electron as well. So to balance it, I would just have to multiply this one by 5. So that means I should have 5 NaCls. And I should have just 1 NaClO3, one of these Cl. So this would be balanced electron-wise. So there's 5 Cls becoming Cl -1, and there is 1 Cl that is becoming Cl +5. In total, you have 6 Cls. So your starting point had 6 Cls, 5 of them turned into Cl -1, 1 of them turned into Cl +5, and that's it. Your equation is balanced. Okay. तो clear है disproportionation? Is this clear?
Yes,
Yes,
sir. But there's 6 and the NaOH
Acha,
as well.
sorry, I didn't. Acha, whatever's left, you just balance it the normal way. So you got how many NAs? You got 6 NAs on the right side. So you're gonna have 6 NaOH and I guess 3 H2Os, right? Okay, now it's balanced. So we're done with it. We're gonna come back to this. We're gonna keep doing this. This is like basic stuff, TK, for A2 electrochemistry. So now, when it comes to A2 electrochemistry, it's all about. So I told you that if I show you an ion, TK, this is now A2 electrochemistry. Now the question is, what does it want to do, right? I mean, the question is, if I want to make a redox reaction, previously, every time you studied redox reactions, the reactions were always in front of you. TK, these equations were given to you. You didn't actually have to figure them out, right? Now you would have to they're going to ask you to figure what's going to happen, right? So if I tell you that there's Al plus 3, so the question is, does it like to gain electrons? Or lose electrons? And if it likes to gain electrons, then is it a strong reducing? If something gains electrons, that's an oxidizing agent, right? So if it likes to gain electrons, is it a strong oxidizing agent? Does it really like to gain electrons, or does it just barely gains electrons? So the idea is we just need to, for every element, every compound, I need to figure out what it wants to really do. Like if I tell you I've got PbO2. So again, the same question, what does it want to do? Does it like to gain electrons, or does it like to lose electrons, right? Now, for some of the elements, we already know what they like to do. Okay, if I tell you what sodium wants to do, तो क्या करना चाहता है sodium? Does it lose electrons easily? Is it very reactive? Does it like to lose electrons or not? Okay, what do you know about sodium?
Yes.
Okay, so मतलब कुछ elements के बारे में you already know okay what they want to do, right? You know sodium, it vigorously wants to lose electrons. So strongly So it very strongly likes to lose electrons. And you will be able to predict that this is what sodium wants to do. Sodium wants to turn into sodium plus 1 ions. But you only know this for very few elements. You don't know it for most of the compounds, what they want to do. Cl kya karna chahta hai? What does Cl want to do? Well, Cl
Likes to gain electrons.
it's a very reactive element. It always likes to gain electrons. It doesn't want to be in the form of Cl. Normally, you always find it in compounds. You always find it in the form of Cl minus 1. So it strongly likes to gain electrons. And we kind of know that if you've got chlorine diatomic, it gains electrons and it would become 2Cl minus 1. ठीक है, अगर मैं gold दूं ना, what does gold want to do? We know it doesn't like to lose electrons. It wants to remain, it doesn't like to form ions. So some of the elements we kind of know, we can predict what they want to do. But for most of them, we can't really figure out. So one thing is, we need to answer 2 questions. One is that, what do they want to do? And remember, it's a relative thing. Remember, the whole idea is a relative thing. If I tell you, if I want to compare sodium and potassium, then potassium likes to lose electrons even more compared to sodium. So it's a relative thing. Who wants to lose electrons? Who wants to gain electrons? By what tendency do they have to lose and gain electrons? So it's a relative thing. So I need to assign a quantitative value, a number, a measurable thing to each element. So I can figure out what they exactly want to do. So for that, you have things called standard electrodes. To measure this tendency, you're going to construct standard electrodes, and you're going to measure. You're going to use them to measure standard electrode potentials. Which is going to be referred to as E naught. So it's going to be E. The naught on the top means everything is being measured under standard conditions. So E is the potential difference. So let me explain what this is. So let's think of sodium. I'm making an overly simplified electrode. Sodium is it's a tough substance to deal with in the lab because it's very explosive, right? So, sorry. So the sodium electrode would probably not look like this, but in reality, so this is an overly simplified diagram. So I've got just a second. इसको छोटा कर ले. I've got this piece of sodium. And I'm going to take a solution, and that solution is going to contain sodium ions. How is it going to contain sodium ions? So maybe it's NaCl aqueous. So there's going to be a lot of sodium ions around. Okay, so there's a lot of sodium ions in the solution. So my question is, like, I'm setting up this electrode. I've got a metallic bar. I've dipped it into a solution. Two things can happen depending on what it likes to do. Either sodium would lose electrons and turn into sodium ions. So that would indicate that it likes to lose electrons. Or the sodium ions that are in the solution would gain electrons and they would turn into sodium back again. So there are two options, right? So in the what option? I mean, you already know what sodium likes to do. So which of the options is the more reasonable option? दोनों में से क्या होगा? Will the sodium lose electrons, or will the sodium ions gain electrons and turn back into sodium?
Lose the first one.
Okay, so it's going to be the first one. We know that it's very, very reactive. And this is what happens, right? Not this thing. This is not going to happen. So I'm going to rub this off. So this is less likely to happen. Sodium wants to lose electrons a lot. Now, as soon as I dip the rod in the solution, sodium would start to lose electrons. So there's going to be more and more sodium ions getting produced. So what is happening is that the sodium electrode has started to dissolve because sodium really likes to lose electrons. Now, at the moment, there's nobody gaining electrons. There's no one around that's gaining electrons. So where are the electrons going? I mean, sodium is losing electrons. So the electrons are not going anywhere. The electrons are kind of getting, they're accumulating on the metallic rod. They're becoming part of the delocalized, because there's no species at the moment that's capable of gaining electrons. There's no reaction happening. We just know that sodium likes to lose electrons. Sodium started losing electrons, started turning into ions. And all these electrons that are being lost, they're just hanging around. They're just accumulating on the metallic rod. And as they accumulate on the metallic rod, and why would they accumulate on the metallic rod? Because the metallic rod already has a lot of delocalized electrons. So it can possibly accommodate a few more electrons, right? So there's the electrons that are building up. Okay. Yeah, clear? Is this clear? Humaid, is this clear? Asina, clear? Saad, Harun, is this clear?
Yes, sir.
Okay. Now the thing is that your rod is now becoming what? It's becoming negatively charged because there's slightly more electrons on the rod, right? Because sodium started to lose electrons. And what's happening to your solution? Your solution is becoming more and more positively charged because the number of positive ions in the solution are increasing. Now, this process will not just happen endlessly because, I mean, it's not that every single atom of sodium would lose electrons, and there's a reason why. Because every time sodium loses electrons, the rod has a bigger negative charge. And every time sodium loses electrons, the solution has even more sodium ions. So it's not going to continue endlessly because the negative charge will continue to become bigger and bigger. So as it continues to lose electrons, your negative charge continues to increase. Eventually, there's going to be a point where the negative charge would become so big and the positive ions and the positively charged solution would become so big that they will start attracting the electrons back again. So the sodium ions that were being lost initially, I mean, they will be lost. They'll continue to lose electrons, but at a certain point, the electrons would be so many, the negative charge would be so big that it will start attracting the positive ions back again. And that's the point when an equilibrium would be established. So the process is not going to happen endlessly because remember, firstly, there's no species there that's gaining electrons. So the electrons are just hanging around, they're accumulating, they're becoming bigger, the negative charge is becoming bigger. At a certain point, the negatively charged rod, metallic rod, starts attracting the positive ions back again. And that's when you get an equilibrium, when both things start happening together. Is this clear? Saad, Ahmed, Tasneem, is this clear? Harun, clear?
Yes, sir.
Yes, sir.
Yes, sir.
But since sodium had a tendency to actually lose electrons, what has happened is that, I mean, there's going to be a certain time, but eventually an equilibrium would be established, but the rod will accumulate a few electrons, a few extra electrons, and the rod will have a negative charge. So the negative charge kind of indicates that sodium really wanted to lose electrons. That's why it was becoming negatively charged. If it did not have a tendency to actually lose electrons, the metallic rod over here would not have had a negative charge. So this negative charge kind of indicates that it's got a tendency to actually lose electrons. All you have to do now is take a voltmeter and just measure the potential difference. Sorry. So we can take a voltmeter. You just remember that's a voltmeter, and we can connect it with the reference point and we can measure the voltage. This voltage is known as our E naught. And it has a standard E naught that it has a particular value. When you make a sodium electrode, although remember this is an overly simplified diagram. Sodium tends to explode when you put it in aqueous solution. So this is not exactly how it's going to happen, but it's an overly simplified version. Sodium's electrode potential is minus 2.71 volts. So when you do this, you get a negative voltage on the electrode. And the negative voltage indicates that it really likes to lose electrons. Or we can say the lower voltage or lower potential, not voltage. So now, if you know about the reactivity C's, does potassium have a bigger tendency to lose electrons compared to sodium, or okay, is potassium? किसी को पता है, does potassium have a bigger tendency to actually lose electrons? Or not? Anyone? Ahmed, क्या होगा potassium? If I had potassium in place of sodium,
It would increase.
okay, potassium has an even bigger tendency to actually lose electrons. So if I had potassium over here, then the electrode of potassium would have even more electrons because it's got a greater tendency to actually lose electrons. So the potential that's going to build up on potassium is going to be even more negative. Okay, so that's going to be an even more negative potential, and so all these potentials are calculated. Okay, so let me just show you. कहाँ पे एक second. Just 1 second, data. So if you, although it's going to be printed next to your question, but if you look at the data booklet, let's only discuss species that want to lose electrons, right? So look at potassium over here. Potassium, this is potassium's, I mean, this is how it's going to be written. Potassium in equilibrium with its ions. So it's got a very negative 2.92 voltage. So that means it's got a very high tendency to actually lose electrons. It really you can compare it with the other values. It's got the lowest potential. So that means it really likes to lose electrons. Even look at lithium. Why do most of your batteries are made out of lithium? Lithium has one of the greatest tendency to actually lose electrons. Lithium has a very high tendency to actually lose electrons. It's got a very low potential. Low potential indicates that the thing really wants to lose electrons. Look at transition metals like manganese over here. Manganese, not that low. That means it likes to lose electrons, but not that much. Okay? So there's not going to be a lot of electrons that would accumulate on the metallic rod. Yes, sodium, that's minus 2.71. We can also have a look at aluminium. Aluminium must be the first one. The second one. That's minus 1.66. Barium 2.90, that also likes to lose a lot of electrons. Okay? So the idea is, the more the substance likes to lose electrons, the more electrons would accumulate on the metallic rod, and that's going to bring the potential very low. Okay, so is this clear? This first better concept, is this clear?
Yes.
Yes.
And then the second one, what if a substance likes to like really gain electrons? So now I'm going to because drawings are important. So the first one I've drawn, that's basically a type of electrode, a drawing that you're going to make where a metal would be in equilibrium with its metallic ions. So the electrode is going to be made out of the metal. So an electrode is something where potential could build up. So the metallic rod has delocalized electrons. If you put too many electrons over there, it's going to become negatively charged. If you remove electrons, it's going to become positively charged. So the metallic rod itself is the electrode. So now if substance wants to gain electrons, what's going to happen in that case? So if we have a substance that, and let's take Cl. So I want to figure out this thing. Do the chlorine gas molecules, do they like to gain electrons? Or vice versa? Okay, so the opposite is that I want to figure out, do the Cl ions want to actually lose electrons? Now, I'm pretty sure that the first thing is the more likely one, that Cl2 has a tendency to actually gain electrons. You just Cl minus one and it doesn't really like to lose electrons. If it wanted to lose electrons, it would have done. Your table salt would not exist. Table salt has Cl ions. They just remain Cl ions. Nothing happens to them. So we know that they don't like to lose electrons. Okay. So what I'm going to do is I'm going to build an electrode. So now in this case, I'm going to use a gas jar. Why? Because there is a gas. Okay. So the gas has to be kept in a gas jar. So यहाँ पे ना there's Cl2 gas. The Cl ions are in the solution. Okay, so your Cl ions are part of the so they are part of the solution. Except for one issue now, okay. So imagine these chlorine molecules coming in. They want to gain electrons. So who's going to give them electrons? Like, where would they gain electrons? There's no one giving them electrons at the moment. Okay, we know that Cl2 wants to gain electrons, but somebody has to give them electrons. So what you do is, because there is Pele case mein, there was a metallic rod, right? But now the problem is that there's nothing there, right? So there is no electrode. So what you instead do is that you insert an electrode. But you want to insert an electrode that is inert. I mean, that itself it's an electrode, it's a source of delocalized electrons. It doesn't do anything else. So what we do is we add the inert platinum electrode. Now it's a metal, so we know that it's got delocalized electrons. So as soon as the chlorine molecules come close to it, these chlorine molecules will start to gain electrons. And they will start turning into Cl ions. So those Cl ions will start going into the solution. They'll start dissolving into the solution. And since these chlorine molecules, the ones over here, they are gaining electrons from the platinum electrode, the platinum electrode would become what? It would become positively charged. So there's going to be positive charge that's going to build up. So more and more chlorine molecules come in. They like to gain electrons. They gain electrons from the platinum electrode. The platinum electrode becomes positively charged. And the positive charge keeps on increasing because they keep taking the delocalized electrons from the metallic rod and they keep turning into Cl ions. Yeah, clear? Is this clear? The whole process, is this clear? Umaid, clear?
Yes, sir.
So the metallic rod is becoming positively charged and your solution is becoming negatively charged, right? And eventually there's going to be a point where the positive charge becomes really, really large. And the solution will have too many Cl ions and the solution will become very negative. At a certain point, the positive, the rod over here, the metallic rod over here, wants the electrons back because it's too positively charged now. So it's going to take the Cl negative ions and pull electrons out of it. So that's when the reverse reaction also starts. ठीक है, remember the reverse reaction was never going to start. The only reason it's starting is that the metallic rod became too positively charged. It became too electron deficient. It wanted, I mean, it was attracting electrons very strongly, so it started pulling electrons back from Cl ions, and you got a reversible reaction. Now, all you have to do is you just have to measure the voltage. Let's see here. So, bus attach a voltmeter, measure the voltage, and you'll get your E naught, which in this case is 1.36 volts. So positive voltage, positive E naught, or higher voltage, higher potential indicates that the substance or the element so the substance wants to gain electrons. And the higher the tendency for it to gain electrons, the more positive the potential. So if the substance really likes to gain electrons very, very strongly, the electrode over here would become even more positive. ठीक है, तो idea clear, summary ये, you got a substance that likes to lose electrons, the electrode would become negatively charged, and it's going to have a very low potential. If you got a substance that likes to gain electrons, then the electrode would become positively charged, and the electrode would become positive, or you're going to get a higher potential. ठीक है, ये clear है? Is this clear?
Yes.
Yes.
ठीक है. अच्छा, and this is, I mean, this is the basic concept. We just did the basic concept, but this electrode or the drawing of this type of electrode is required when you have a gas and aqueous ions. So whenever you have a gas, like in the reaction, or the substance is a gas, and it's an equilibrium with its aqueous ions, then you would have to draw something like this. You're going to have to insert a platinum electrode because there is no electrode, so you would have to add an inert electrode. There's going to be a gas jar. Okay, we'll come to drawings later. Okay, so that's it. Let me just show you positive potential. Look at Cl2, that's 1.36 volts. So let's see if something, look at fluorine. Fluorine has an even greater tendency to actually gain electrons. So fluorine has an even more positive potential, that's plus 2.87. Acha, who else who's got a very high potential? KMNO4 has a very high potential. That's it's got a very high tendency to actually gain electrons. Both of them, 1.67, 1.52. It was a good oxidizing agent because it wants to gain electrons. Okay, so anything that wants to gain electrons will have a very high potential. ठीक है, तो बस इसको summarize कर लेते हैं. That's just the basic concept, very basic concept, and that's pretty much it. ठीक है, the rest is just the rest is all about how to answer questions and the details, right? But the basic idea is you just have to remember this thing. Negative or lower potential indicates that it wants to lose electrons. Higher potential indicates that it wants to gain electrons. That's it. That's the whole idea. Okay, so that's pretty much the whole summary of what electrochemistry is. Baki, there's a lot of details, and we're going to talk about those details moving on. Okay, लेकिन अब ये clear है सारों को? Is this clear?
Yes.
Yes.
Yes, sir.
So चले ठीक है. अच्छा, वो I've just changed my laptops, तो वो video lectures, I'll share them again. ठीक है? I just need to sort of get my folders back. तो वो मैं send कर दूंगा उस पे group पे, ठीक है? चलिए, okay everyone.
Thank you, sir. Allah Hafiz.
ठीक है, Allah हाफिज.
Allah Hafiz.